Welcome, and thank you for stopping by. We've made some pretty bold claims, and you probably want to see for yourself whether the actuator is for real. We've put together this series of demonstration videos to walk you through the actuator's capabilities. In this first video, we will review the special properties of inverts and show you how to build invert structures that can model practically any concept you need. We'll also show you how the Invert Builder tool provides firm guidance in helping you to build specifications that make sense. Here we are looking at the Invert Builder tool. Inverts are the building blocks for specifying your software. They are a special type of visual component and are unique to the actuator. There are over 1100 of these inverts, and they are organized into libraries shown in this panel to the left. Inverts cover a broad range of components and allow you to model practically anything you could accomplish by coding. You'll notice that some of the library headings are shaded in yellow. These represent invert types. There are fundamental types like numbers, arrays, tables, text, and booleans. There are also some more sophisticated types like file I/O, probability distributions, random numbers, yield curves, mortality rates, annuity types, and so on. Let's take a quick look at the probability distributions library. The 50 different distributions here give you some clue as to how rich these libraries are. Now let's take a close look at some of these inverts. Most inverts have perhaps 1 to 4 attributes that are needed to fully specify them. When we click on an attribute, you can see that it gets the focus and the border changes to red. You'll also notice that down at the bottom of the screen, the required type for that attribute is displayed. Sometimes the type is even more specific. Here you can see that the column number of the table column invert must be a positive integer. How do we specify an attribute? Well, there are 3 ways. The first way is by using another invert. Here you can see from the bold blue labels that these attributes have been specified using an invert. This is easy to do. You simply select the attribute, select the invert template from the library, and click. I'm just going to quickly insert some inverts at random here. As you can see, this is all quite simple and intuitive. Most attributes are of a fundamental data type and can also be hard-coded. Here we see a ratio of 2 hard-coded arrays. Let's hard-code a couple of other attributes. The third way is through a reference to another invert elsewhere in the structure. Built-in controls prevent circular references or chains of references. This ensures that each piece of information is in one place only. For most inverts, you are required to specify all of their attributes. However, some attributes can be optional. In this example of a sorted set, you have the option of specifying that it be sorted in reverse. Optional attributes are indicated by the grey label shown in italics. This is also indicated on the status bar at the bottom. Notice also that its border is yellow and not red. More on that in a minute. To help manage screen real estate, some invert names have been abbreviated, so detailed tooltips are provided for all inverts. You can manage the complexity by opening and closing any invert in an invert structure. A red border indicates that not all required attributes within a structure have been fully specified. A yellow border says that it is fully specified. These colored borders give a quick indication of what you still need to do. You can delete the contents of an attribute and replace them. Some inverts have special repeating attributes that are shown in blue. Here you see the average 3+ invert. If you want the average to include more numbers, you can just click on the plus button in the toolbar. There is one other useful type of attribute, and we call that a palette. You can add a palette to any invert, and it can be of any type. Think of it as a kind of scratch pad. To create it, we first select the invert that we want to add it to, select the yellow type library, and then click the palette button on the toolbar. If we want it to represent a set, then we instead click the palette set button. Obviously, if you want to insert an invert, then it must be of the right type. The next video will show a practical use of this feature as well as some other special types of attributes that are used with files and databases. A good example of the versatility and richness of inverts can be seen with the various types of numerical structures. Here we see the invert libraries for various numerical structures such as arrays, tables, sequences, etc. They can require a lot of complex logic involving iterative loops and sorts, sometimes 3 or 4 levels deep. For human coders, this is where a lot of errors are made, but inverts do not require any logic at all. You just say what you want and not how to do it. All you need to do is connect them together. Many of these inverts allow you to specify a numerical structure in terms of one or more other numerical structures. Let's look at a few examples. Here you see an array defined as the highest 2 values from a target array, 169374. In this second example, you see an array formed by extracting a column from a table. You can start counting from the front or the back. In the next example, we see a table formed by deleting one or more rows from another table. And in this one, we have an array defined as a row from a table. Notice how we have specified the table using the previous invert. There's no limit to how deep you can go. There's no logic needed anywhere. If you've ever struggled with a spreadsheet full of repeating formulas, you'll appreciate how clean and elegant this is. To illustrate what is possible by combining inverts, let us consider the following simple-looking problem. We want to get the 3rd Saturday of the following month after your next birthday. How might you document this? How might you code it? It's more involved than it might first appear. You may need to handle leap years. You'll need to check whether your birthday is earlier or later in the year than the current date, or perhaps even equal. And you'll need to determine what day of the week the next month starts on. Finally, you'll need to roll around to the following Saturday before adding 21 days. Or you could just do this. Let's look at another one. You want to look at average vehicle speeds at an intersection over a 1-hour period, and so you've decided to use a harmonic mean. You want to set a minimum speed and a maximum speed to reduce the influence of outliers. Here's how we would do that. The harmonic mean is a measure of central tendency that is suitable for data such as speeds, and for its data, we will specify a Windsorized set that allows us to apply a minimum and maximum speed for our analysis. We could hard code these values, but let's say they are some function of the prevailing speed limit. So we'll create a palette attribute and put in a speed limit of 50, for example. Now we'll apply a maximum speed of 120% of the speed limit, and similarly, let's apply a minimum speed of 50%. So anytime we look at a data set from a location with a different speed limit, this is all we need to change. Now, some experienced programmers might say, aha, we have libraries of subroutines that can do some of these things. Perhaps you do, but you have to dig out these subroutines, know how to use and combine them, integrate them into your code, compile and test them, and then deal with the project management involved in getting your code accepted and moved into production. That's not easy. This is easy, and you get immediate results. In the next video, we'll show you how to create executable programs that can read and write to files. In later videos, we will build executable models for complex databases, set manipulation, and Monte Carlo modeling. We will also introduce you to specialty libraries covering statistics, investments, derivatives, and more. We'll see you then.